So this is our first track today. So buckle up and let's have a great ride. The talk is called Where's My Crypto Dude? The Ultimate Guide to Crypto Money Laundering. Hopefully no one from the IRS is here. And the speaker is Thomas Roccia from France. And let's give him a big round of applause, huh? And thank you guys for showing up today, making DEF CON great again. There you go.
Thank you. Hello everyone and welcome to my talk. I'm super happy to be here today. This is the second time I'm speaking on the main stage on DEF CON, and this is a real honor, so thank you very much for coming today. Yes! Thank you! It's been a long week, so thank you very much. All right. North Korean attackers have been targeting cryptocurrencies for a while to finance their operations. Last February, they stole $1.4 billion from the Bybit exchange, and they laundered the money very fast. In about a minute, they transfer all that money through thousands of wallets, and no one was able to understand where the money was going. So I wanted to understand and to see how cryptocurrency and money laundering is possible on public blockchain.
Sorry, give me a second.
Yeah.
The screen's not displaying properly. Sorry, guys. You're not seeing the screen properly. First track of the day, always the case. Is there a button? Is there a button here?
Screen mirroring.
Right click. It's a button. I knew there was a button. Yes. What? Let's do it. There we go. Clicker. And you are presentation. Okay. Full screen.
Let me do it.
Yeah. Sorry about that, guys.
All right. IT is hard, isn't it? All right, let's start again. North Korea attackers have always had an interest into the cryptocurrency market to fund their operations. Last February, they stole 1.4 billion of US dollars from the exchange Bybit, and in a minute, they laundered the money transferred through thousands of wallets. It was very complicated to track the money. So I wanted to understand and to see how crypto money laundering is possible on public blockchain. And I also wanted to understand what was the techniques they used to obfuscate the trail and avoid the tracking of the money. So I built a tool. I built some tools and tested with AI agent. I know, it's kind of everyone is talking about agent and AI today, but that's what I did. And I used that to help me follow the money and assist into the analysis. So today, we are going to explore the story, the tools, the tricks, and we are going to try to answer one question. Where's my crypto, dude? Okay, let's get started. A brief introduction about me. My name is Thomas Roccia. I'm a threat researcher at Microsoft. I've been working on threat intelligence for the past 15 years, and I've been focusing on AI and how to use this technology for any kind of investigation and threat intelligence. So today, I'm going to explain a little bit more about some of the work I've been doing. And if you want to see my past work, you can check my website on securitybreak.io, or you can follow me on Twitter. Okay, the agenda for today, we are going to see an overview of the Bybit case study just to understand how the attackers was able to steal the money. Then I'm going to focus on crypto money laundering techniques, and we are going to see 6 techniques just to understand how it works and what we can do to track the money. And at the end of the presentation, we are going to try an AI agent that I coded that could help an analyst, and I will conclude the presentation with a takeaway. But first, the Bybit case. If you haven't heard about it, it was back in February 2021. And during this day, someone from Twitter, which is a really well-known investigator called ZachXBT, discovered that a huge amount of money was going from a Bybit wallet to an unknown wallet. And it was unusual because this amount of money on blockchain is not something that happens on a daily basis. So he mentioned that on Twitter, and it rapidly blew away, and people were trying to understand what happened and so on. The next day, Bybit officially announced that they have been breached, and they detected an unauthorized activity within one of their Ethereum cold wallets. The transaction was manipulated by a sophisticated attack that I will show you right after, and the money was told, the amount of money was about 400,000 Ethereum, worth about 1.4 billion of US dollar. About the timeline, how the attacker breached Bybit and how they stole the money. Actually, they breached a third party used by Bybit for cold wallet signing. They breached Safe Wallet. So in February 2, one of the developers from Safe Wallet downloaded a compromised Docker project and got infected because of that. During the next few weeks, from February 5 to 17, the attackers did some reconnaissance inside the Safe Wallet environment. They looked for the AWS infrastructure, they mapped everything, and they identified the web interface used for the client of Safe Wallet. And they were preparing for the next phase, which is the JavaScript code obfuscation injection on February 20. What they did, they manipulated the web application to inject with the code, and so the code was actually waiting for a Bybit wallet to connect to it to execute. So this code was specifically crafted to target Bybit. In February 21, this is the day they were able to stolen the money. The hack was exploited, and they did the transfer to one of their wallets controlled by the attacker. And February 21, everyone was starting to understand, to check what was happening, and everyone was starting to investigate the case. To deep dive a little bit into the details of the attack, let's have a look to the 6 phases of the attack in this slide. First, we have the off-chain attack. This is where the attacker compromised Safe Wallet to monitor the Bybit wallet to be connected and to change the behavior of the web application. Then we have the Bybit cold wallet. Bybit is using a cold wallet to store a lot of money, and they are using a multi-signing through the master copy, the Gnosis Safe wallet, to do large amount of transactions. What they did a blind signing, which means they haven't been able to verify where the money was going. And then, during the signing, they activated a delegate call. This delegate call loaded the attacker's contract into the transaction. And when this attacker's contract was loaded, it rapidly executed 2 functions, which is sweep ETH and sweep ERC-20, to do the transaction to one of their wallets. And boom, just like that, 1.5 billion of US dollar was going somewhere. Okay, so this presentation is about crypto money laundering. So right now we are going to focus on 6 techniques that have been used by the attackers. The first one is immediate asset conversion. Just after the initial transaction to one of the attacker's wallet, what they did multiple other transactions to different kind of tokens. So what you can see here, you have multiple transactions to STETH, USDT, and so on. With that, they were able to spread the money through multiple tokens and through multiple wallets as well. One of the tracking opportunity to that is to identify some timing correlation, because this kind of amount of transaction is doing it with a script. So you have some timing correlation because all these transactions will happen at the same times or very close to each other's. Then you can also monitor DEX transactions, monitor Uniswap. DEX is for decentralized exchange. You can monitor Uniswap, SushiSwap, and so on. Volume pattern analysis, because the amount of money like that is very interesting. And since the money is spreading between multiple tokens, you are able to identify some patterns that can be suspicious. And then, of course, some wallet clustering, because when you identify some wallets that are from the same attackers, you can start to have some intelligence and connect the dots between the clusters. The second technique is the money dispersing. So what they did after the initial hack, they spread the money through multiple wallets with different amount of transaction. So rapidly, after the first transaction of 1.5 billion dollars, they sent to 50 initial wallets with an amount of 10,000 K of Ethereum, 10K Ethereum. And then after that, they split again until they reach like a large amount of wallets. So as you can imagine, when you do that in a very short period of time, it's very difficult to track the money and to identify where the money is going. Some tracking opportunity, you can identify the token flow, where the money is going, try to track where the money is going from a wallet to another wallet. Monitor gas usage, since all those transactions are automated, then you will have a gas usage which is similar for most of the transaction. Temporal clustering, because these transactions have been done in a short amount of time, so you can do some analysis through the timing as well. Multi-hop analysis through multiple wallets, and then visualizing some of the data, trying to track where the money is going. This is some of the method you can use to track the money dispersing. Another technique DPRK used is the cross-chain bridge. The initial amount of money was in token and Ethereum. And what they did, they transfer through cross-chain, they actually transact through cross-chain the Ethereum to Bitcoin, because Bitcoin is one of the favorite money for North Korea. And this is exactly what they did. So to do that, they use a cross-chain bridge. This is where you are using, when you are transforming Ethereum to Bitcoin. And then they use chain flip, multi-chain, and some others. They also use wrap token to do the transaction and get Bitcoin exchange to have the money on the Bitcoin blockchain. Some of the tracking opportunity to do that. One of them is to monitor bridges to see where the inflow and the outflow. So you have an Ethereum wallet with a certain amount of money, and then you check the Bitcoin wallet, which could be related through the cross-chain bridge which is used, and see the amount of money between them to correlate that the money was going to this wallet. You can also label known DPRK wallets. So since everyone was actually working on this investigation, and you was able to identify some previous wallet that was previously identified by the researchers and by some companies, you can also leverage API intelligence for blockchain. Then you can correlate patterns to make sure you have some information that could be useful for your investigation, because you will be able to identify where the money is going by tracking some of this information. And then track the token flow, which is the tokens transfer that have been used to convert to Bitcoin through cross-bridge and so on. The next one is the usage of know your customers platforms. North Korea attackers, what they did, they used the exchange platform, which is a platform that doesn't require any identity to use. So it was very interesting because it's a platform that claim that they are using confidentiality and so on. So it's a very interesting platform for people that want to launder the money, because you don't have to prove who you are or to give an ID. Which is interesting with this case is the amount was so big that the platform was temporarily overwhelmed by the amount of transaction. Kind of interesting. To track this kind of transaction, what you can do is to flag all the wallets, the deposit wallets from the X platform, and try to correlate with all that money. Check the outflows in Bitcoins, because remember, they want to convert to Bitcoin because this is their favorite money. And then reconstruct the swap flow as well, ETH, swap bridge, and so on. The fifth technique is using mixers and CoinJoin. So CoinJoin is actually a platform where you will be able to send some money, and in your transaction, the amount of money you are sending will be merged with some money from someone else. So it's make more difficult to track the money because the initial money that you are sending is mixing with another transaction. And a mixer is almost similar, except you send your money to a platform, and this money will be inside the platform. This money will be exchanged and transferred to multiple wallets until they get back to another wallet outside of the mixer itself, and the money will be clean. So it's more difficult for analysts to track where the money is going because there is multiple transactions doing it, and and the money will be kind of clean after this kind of mixing. Some of the tracking opportunities, you can use heuristic analysis to apply, for example, some statistical heuristic to identify which wallet was pre-mixer and which one was after, and some wallet behavior pattern as well. You can also flag all the mixers, contract, and wallets if they are known, such as Tornado Cash or some others. And you can also do some taint analysis to see where the money is going and try to track the money from A to Z. The last part of the money laundering is the OTC cash out. So as you know, for when you are launder the money, at some point you will need to have some fiat money. You need to have some US dollar or euro, whatever. So the attackers needed to have this part at the end, and DPRK is using some OTC cash out region, such as Southeast Asia, Eastern Europe, or Latin America. And what they were doing, they are actually using small businesses to send the money, and these small businesses get out the money in US dollar and so on. So it's more difficult from us to track this money because at some point when the money are out of the blockchain, then you lose track, and this is another way to track the money. But from that, you can potentially identify OTC brokers through that specific region, identify known wallets, and try to make some correlations. All right. This is the 101 for laundering your crypto money. Right now, I'm going to talk about an AI agent to help an analyst tracking the money. So let me explain what I did. I built an AI agent, which is powered by an LLM. And if you are not familiar with an AI agent, this is basically an autonomous LLM system that will reason and act, and based on the observation will reason again and act again. So it's basically an LLM with some reasoning function connected to some tools that will be used during the investigation and the task we are giving to the user. And these tools will feed the observations. This observation will continue through the reasoning process, and so on and so forth. So what I did, I created an AI agent specially crafted to track crypto money laundering, and I connected my AI agent with multiple functions. The first one that I did, I connected my AI agent to context storing to make sure it keeps track of everything. Because as you can imagine, when you are investigating a blockchain transaction, it's a huge amount of data, and it's kind of complex to follow everything and to keep track of everything. So first thing that I did, connecting something for my agent that let it know and understand what was the previous steps and how to store the context which is currently ongoing. Then I connected my AI agent to some toolings. And first, I connected to some of the tools to the Etherscan API to look for the Ethereum transactions. And then I also connected it to some blockchain intelligence platform, some blacklist, and some custom code that I did to identify some patterns in the transactions. And at the end, I also have a way to report all the information and to create a report with all the data, so the analyst can investigate a little bit deeper or have something which is a little bit more interesting to read. and also graph visualization, because when you do some blockchain analysis and transaction, it's really cool to see where the money is going. To connect all that tools to my agent, I use Model Context Protocol. So if you're not familiar with MCP, it's a standard protocol to connect AI system to some tools. And this is exactly what I did. I created 3 MCP servers. The first one is MCP Etherscan, connected to Etherscan to look for some transaction and get back this data. I connected it also to some blockchain intelligence to look for a known wallet, to label some information from the wallet itself. And then I also created a custom one for money laundering schemes. So I built some detection to identify the money distribution, the gas fees, the wallet clustering, and so on. So now this is the demonstration. So right now what I'm doing, I'm running my AI agent. And then this is my MCP servers. The first question I'm asking is, can you investigate this wallet? And then I pass the first wallet from the initial transaction. What is going on here? The agent is actually executing the tools that I created. You can see some of them on the screen. And then we have the investigation result. Right now he's asking to continue the analysis because he was loading the tools. So I'm asking, check the amount of money, then identify the 10 biggest transactions from this wallet, the one we previously specified. So right now he's still doing some checking, and then we have the 10 biggest transactions, as you can see here, from this initial wallet, the Bybit, the threat actors wallet, and then we can see the date, which is close to, which is the day of the transaction, the initial transaction, and then we have the amount, which is 10,000 ETH amount. Remember the money dispersing techniques. Then I'm asking for all those 10 wallets, tell me if their wallet. Tell me their labels, sorry. Tell me if these wallets are already known. So when I ran my agent, it was yesterday night, don't tell anyone. And so the labels were already flagged. So here we have an example where we can see, okay, this wallet is the Bybit exploit, and so on. So here I'm connecting to some blockchain intelligence to get that information. The next question I'm asking is now follow the money for the wallet, the initial wallet that we have, to the 5 biggest transactions. So right now I'm asking this information. Again, my agent will understand my request. It will process the details. He already also kept some of the information we discussed before. So right now he's calling my MCP servers. We have some tool capabilities. And the interesting thing here is that we are storing also this information. So I have a graph, a Neo4j graph, where I'm actually storing the data. So dynamically, my agent will update this graph to follow the money so you can reference to it. The next question I'm asking is, okay, now put the 10 biggest transactions from this wallet into your database. This is the Neo4j graph. Again, the agent is thinking about it, reasoning, acting with the tools, the MCP tools, and the capabilities it has. And then it executes everything. It tells us that the top 10 transactions from the wallet have been successfully stored in the database. And if we have a look to the database itself, again, we update it, and then we have all the transactions that we just asked the agent to put into the graph. And you can see some correlation where the money is going and so on. The next question is from the data on the data set, on the database, tell me if there is some money laundering patterns. So in that case, I'm using one of my other tools, which is identifying some patterns and money laundering schemes. And again, it will call my tool, run everything, pass all that information through the reasoning process, and give back the answer to the user. And then right now, we have some information, which is tempted transaction indicate a medium risk of money laundering activity. We have volume spike, mixer usage, exchange hopping, advanced placement, and so on. And we have some of the wallets also that are referenced here. The last question we ask is now write the report. Give me a full report that I can pass to my management or that I can present somewhere. and then the agent will also do the investigation. Right now we have the summary here on the terminal, and I'm going to show you the HTML page that it created. So we have all the executive summary. We also have a transaction and a graph build from the previous analysis, because it's dynamic as well, so it updates everything, so you can see where the money is going. We have the transaction analysis, where we can see the types, ETH transfer in that case, smart contract, interaction, mixers if there is, some patterns analysis, as you can see, and timing analysis as well, so the amount of money transacted, and some money laundering indicators, and finally some basic recommendations. So this is how it works. This is an agent, and thank you. Now keep in mind this is a proof of concept, and it's quite complicated to automate everything. And the first thing is because identifying all that money flows is very complex and very hard to understand. The other thing is there is a lot of data, and when there is a lot of data, you have to store that information somewhere, and I get limited by the resources because at some point I wanted to load a big graph into my machine, and my machine just crashed because the graph was too big. So for this kind of hack, 1.5 billion of US dollar, it's huge, and it's really difficult if you don't have the right resources. The other one is that the obfuscation and everything make it a little bit hard, so you have to focus on some specific transaction or specific wallets to make sure you identify some information. And then the cross-chain moves is more difficult as well, because that means your tools needs to be connected to multiple exchange platforms and so on. And right now in the proof of concept, I used only Ethereum blockchain. And then you can miss some context because in some cases the wallets can be dormant and the money will be potentially transacted in the future. So when you, for this agent and this proof of concept, when you are using it, it's on right now and not in the future. And of course, API limitations. It's very expensive to use some APIs to connect through blockchain intelligence or to connect to even to the blockchain as well. So that's one of the resources as well, and it can be very slow because you are limited into the way you are requesting the API. And of course, the last one, which is the heavy infra. Remember the graph. Neo4j is not good for a large amount of data. So at some point, you will need to move to something bigger, which is more reliable for your investigation. I think right now you have everything to understand money laundering, and especially this case. There is still a bounty open, so with all that information, you can potentially contribute to the money tracking bounty and maybe get some money. As I said, there is a lot of things to build on top of what I did, which is a proof of concept, but this is still feasible if you have the resources. To conclude, I think this is an excellent case to show that North Korea actors are really serious about hacking cryptocurrency industry. They are really advanced in terms of their techniques, not only for the money laundering, but also for the initial hack. In that case, they were using sophisticated supply chain attacks, and we know they've been really known about this kind of attacks. And then they've been using a lot of complex laundering schemes, which is very interesting when you deep dive into this ecosystem and understand all the money. As I said, this kind of investigation is very complex because it requires a lot of resources, a lot of money also if you are using some APIs. And I think that AI and autonomous system can support investigation because this is an initial step where you have something that can be automated compared to something that we used to do manually. And which is relevant as well here is the usage of tracking the money from a point A to a point B through an autonomous agent. And last but not the least, the amount of transaction currently limits the usage of AI agent and LLMs because the context windows is limited, and in some cases, it's not possible to load everything. To conclude on this presentation, there is a bunch of additional resources if you are interested about this topic. And then you can have a look. There is an excellent investigation on that. And you can also check some of the resources which are here. And I want to thank you, my reviewers, because they've been very helpful for this presentation. The last thing I want to ask you is, with all that information, do you think you will be able to track the money again? And I just want to say thank you for listening me, and let me know if you have some questions. Thank you very much.